Hello everyone, welcome to Clashing Coder. So in this video we will see the question number 17, that is letter combinations of a phone number on the LeetCode platform. So it is a medium level question. So let's see the problem statement. So given a string containing digits from 2 to 9 inclusive, that means we have to include 2 and 9 also. So the range will be from 2 to 9. Return all the possible letter combinations that number could represent. So mapping of a digit to letters, just like on the telephone buttons that we are given, you can see 1 2 3 4 5 6, and why we are not including 1 and 0 is because you see there are no alphabets mapped to 1 and 0. So only we have alphabets mapped from only 2 to 9. So that's why we are using 2 and 9 only, from 2 to 9 only. So note that 1 does not map to any of the letters, so it also states that. So what we have to do is we will be given digit or a string of digits. So we have to we have to output the all possible combinations which can be formed from the alphabets that are mapped to a particular digit. So if you see, 2 maps to A, B, C, and 3 maps to D, E, F. So what we have to do is we have to make all the possible combinations, and length will be similar to the length of the string that we are given. All the strings you can see are of length 2, and our input is also of length 2. So length will be similar. So what we have to see is how to map this. So you can see A maps to B first of all. So A D. So you can see AD. Then A maps to AE. So this is also a combination, and AF. So you can see then BD, BE, BF, and CD, CE, CF. So it is like a cross product. If you have studied in maths, maybe you have studied. So it is like a cross product of all the letters in the first set and the second set. So you can see we have to form all the possible combinations. So it may be given your input can be in like 1 2 3 2 3 4. So then it will be of size 3. All the strings present in the input will be of size 3. So it is given that although the answer is in lexicographical order, that means it is ordered arranged in a dictionary order, but our answer can be in any order, or you can see could be in any order you want. So let's see how we can solve this question. So first of all, if you see this question, so actually for every digit we have to keep the track of which alphabets are mapped to the particular digit. So the word that they have also used here, you can see, is actually, you can see, mapping, a mapping of digit to letters. So how we can map a single digit like 2 to the particular alphabets or letters that are occurring for 2, A, B, C. So for this, if you see, mapping is the keyword that we are using. So this mapping can be done using a hash map or a dictionary in Python. So for that we have to create like a hash map. So hash map, what is hash map? So it is actually a pair of key and value pairs. Actually it is a key and value pair. So our key will be the digit, the digit that we are having from 2 to 9, and the values will be actually from A, B, and C. So what we have to create is, it will be not like A, B, C, we keep them directly. We will make a array or vector of alphabets, then or string or character, actually a character. Then we will save it we will save these A, B, C in that particular, if you see, in that particular vector of characters, because this will be our string, 2 is our string. Then we will map the string with the all the possible letters that are occurring for that particular string. So it will be ABC. So you got to know that we have to use mapping in this. So it states that, so we have to use mapping. And the one more thing that we have to notice is we have to produce all the possible combinations. So it is telling us to explore all the possibilities. So how can we do that? So it can be basically done by recursion, or you can say recursion plus backtracking. So what we have to do is we have to use a hash map, and we have to use recursion and backtracking. So I hope this got the problem clear to you, that how we can solve it. So I also thought of this problem as that I told you. So actually, so then that means we have to create a map for every particular digit, and we have to store all the possible letters that are occurring for that particular map. And you can see there are some letters are having 3 alphabets or letters, some digits are having 4 letters, you can see 7 and 9, and others are having 3 letters mapped to them. So so let's see how we can approach this question actually. So for backtracking, as I told you, we have to use backtracking because we have to produce all the possible combinations for the particular input that we are given. So for example, if we are given the input let's take example of 2 and 4, actually 2 and 3 only, okay, 2 and 4, let's check it. So if we are given input as 2 and 4, so how we can solve it? So if you see, we have to put all the possible combinations. So what are the letters mapped to 2? So actually we will write it ABC. So 2 is mapped to A, B and C, and 4 is mapped to D, E, G, H, I. So 4 is mapped to G, H, I. So now we have to like explore all the possible like combinations that we can form for these particular input. So how we can do that is we will have to explore all the possible like combinations. So first we explore the letters of the 2. So they will be A, okay, just let me write it. So A, and if you see for the particular 2, so it will be A, B and C. These are the possible combinations for 2, all the possible letters that are mapped to 2. Now what we have to do is, it will be like this. Actually, let me show you. So I think I will just give you the indication. Actually, I can draw the whole tree with using mouse. So let's see. So now you have to see that we have explored this particular digit and all the like characters occurring for it. You can see A, B, C. So now we will move to 4. So if you see, now we have got to A. Now what we have to do is we will map all the characters of the 4, or all the like the alphabets that are mapped to 4 for this A. So let's explore them. So it will become A and G. So if you see A and G, then we will call for A and H. Sorry, A and H. Then we will call for A and I. So you see how we can like move to the solution for a particular. So it is actually traversing the solution in a depth first method, you can say, because for recursion we are moving to whole depth that we can. So you can see first we like explore 2. So all the alphabets that were mapped to our ABC. So first we like got to A and check the all possible combinations that we can form from A using this 4 characters. So that were G, H, I. So we got to them. Then we will check what can be our base condition actually. So as I told you that the length of the output should be equal to the, not output but actually all the strings present in our result array should be equal to the length of the input. So length of the input is 2, or you can say 2, yeah, 2. Then it for this also it is 2. So when our length of this current value becomes equal to the input, that means we have explored all the possible possibility or possible combinations for the particular node. So then we will have to backtrack. So if we backtrack and remove G from here, then we go for H. Then we also check this condition is also true. Then we remove H again, and we are adding this also in the result array as we are moving back. So we add the AG and AH also into our result. Then we go to AI. So we again backtrack, we add this into result as its length is equal to the input. Then we backtrack and remove it. So now we have explored all the possible combinations for the A. So now we have to backtrack again, and then we move to B. So now we move to B, then we will check all the possible combinations for B also similarly. So for B also we will move ahead and check B and G. It will become B and G. Then it will become B and H. Then it will become B and I. You can see these are the all possible combinations for B. So actually we are not exploring like I am showing you. We are exploring like first it will go to BG. So then B will go to BG. BG will be added. G will be added. Then we will add it to result as its length has become equal to the length of the digits that we are given. Now what we have to do is backtrack and remove this G. When we remove this G, so it will come here again. So now B will go to, B has not explored all the possible combinations for it particular like character. So it will go to BH. Now again length will be equal to, it will be added to our output. Then it will again backtrack and remove the H because we are backtracking. So we have to remove the step that we did. So we first added the G, then we removed G to backtrack. So now we go to this BI recursively. Then what we do is we remove this I from here and backtrack. So these are the steps that we are using for backtrack. Similarly for C also it will be same actually. Let me write it, and you can see for C it will be C, G and C, H and C, I. So this is what we are trying to do. We are backtracking our solutions because we have to explore all the possible combinations. So when we add C, G to C, then we have to explore H and I also. So for that we have to remove G also. So let me show you. So we were exploring all the possibilities, and you can see when we explore for the C, so we explore all the possibilities for the C and we add them to our output array when their length is equal to the length of the input. So you can see all the length becomes 2. So then we backtrack. When we backtrack from I and we reach to 2 and 4, and we see that we have explored all the possible or all the possibilities, then we can simply return our output. So this is how we are going to use our backtracking, and along with that we will have to use a map also, because for finding all the values mapped to particular digit, so we will search for the 4, then only we can check now how which values or which the characters or the alphabets are mapped to 4, G, H and I. So for that we will use a vector, as I told you, or a vector of characters, or a array you can say. Then let's see how we can code this actually, and along with coding I will explain you step by step what we are trying to do in that particular step. So just a second. So yeah, so this was the question. So yeah, let's see. Let me, so actually for making it like a short video, I have actually created the map that we are going to use, and I have declared it as a global, and our output result or the vector output vector also as a global variable. So you can see I have created the map by using this map of character, because we are using this as a character too, because we will be given a string, so we have to use a character only. So then we will create a vector of string, the vector of string, or you can make a character. So this will be our mapping, how we can do that. So you can see, you can simply, you have to make it manually, because they won't be giving you this. So actually you have to make it like manually, and you can check all the characters for the particular digit from this given telephone. So that so that's it. So you will use this. So now let's start coding. So actually what will be our base condition if we are given we are not given here that we will be not having invalid input? So there can be invalid input also, so you have to check that. So but how can we check that? If our length of digits array is sorry, not array, digits string is 0, then we are given a 0 length input, so that can be like nothing in there, so we will have no combination. So we will simply return our vector of string result. So now what we have to do is we have to start our backtracking solution. So what we have to do, we will have to make a like another function, helper function, for backtracking. So for the helper function we have to pass 3 variables. Actually 0 will be our starting. So how we can check for the particular we have to get the character which we are searching for, like whose possibilities we are checking for. So our this 0, that will be our start variable, will keep the like track of which alpha or digit we are on in the input string. So that's why we are using that, and digit will be passed as it is digit, and then we will pass a simple empty string that will be our current input. So what we will do is we will simply return the result. After that we will fill the result in this helper function. So let's make this helper function. So actually it will be of void type, because we have to not return anything, because we have created this as a global. So let's make a helper function. What we have to input as, you can see we have our arguments will be int start, because we have to like get the count of where our actually pointer is on, which digit actually it is on at the input string. So that will be one thing. And then we have to input or argument, take a string as argument, that will be digits, then also a string that will be current, which will be adding. So actually current will be this thing that we are on. So actually current will contain this a and g. First current will be a, then g will be added to it. So this will be our current. So this will be our current value. So for keeping that, so what can be the base condition? I told you, when our length of the current or is equal to the length of the digits. So actually not the current, sorry, when the length of our start is equal to the length of our like value of our start is equal to the length of our digits, because start is this. So if, so let's see, I will just code it first of all, then you will understand it. So if we'll check if digits dot size is equal to start, that means we have traversed all the possibilities for the particular like node that we are on. So we can simply add the result or add the string to the result, that will be current. Current will be our the current string that we are on, like this. If we are on a and g, we are on h and a and h, then we will simply add it when its length is equal to the digit size. So this will be it. And now let's see how we can like check the mapped characters to a particular digit. So what we can do is we can simply make a vector of string. We have to make the vector of string, because actually we are using here the vector of string. The vector of string will contain for 2, actually it will contain a comma b comma c. So we have to get all the possible the characters in the particular. So we will like make a I will make a short form vect, and then how can we get the particular like characters for our a digit? So we can use simply maps, and we have our digits array. and sorry, string, and then we will use start. Start will be, for example, if start will be pointing on 3, for example, just say it will pointing on 3, so digits 3, oh sorry, start will be pointing on 1, so digits of 1 will be 3. So what will be our value in that map? So map 3 will contain values as D, E, F. So this vector will contain values as for 3, it will contain, our vector will be equal to, it will be containing value as D, comma E, and comma F. So this will be our value at particular, like this for this vector. So now let's go ahead. So now to start our backtracking, or you can say exploring this all the nodes, what we have to do is we have to make a for loop, because we have to traverse over this this vector for all the digits, as I told you, for all the characters in the particular digit. We have to explore all of them. So for this we are having them in the list, so we have to explore all of them. So we have to use a for loop to traverse them. So we will be using a for loop, and its size will be equal to size will be less than vec.size and I++, and then what we will do is we will simply create a string, and then we will make it equal to the vec of I, that will be this. Now our vector of I, or a vec of I, you can say, it will be equal to, first of all, it will be equal to A. For example, it will be equal to A. Then what we have to do is we have to add, actually we have our current variable here, and we will simply add this to our S. So now it will be added to S. So actually current is empty before, so you can see it was empty. So now S will be added. So S is A. So now it will explore for the another possibility. So what will be it? Actually, let me write the code actually first. So you can see we will simply have to we have to keep incrementing this. If you don't increment start, so it will stay at particular digit only. So it will not incrementing, and our size will never become equal to the our start will never become equal to the digits or size. So your answer will not come. It will be actually running infinitely. So you will have to keep that in your mind. So then we will return the digit and our current string, because we have simply added the current, so we can return it, or you can simply skip this statement and write current plus S here only. So now what we have to do is we have to do a backtracking, step. So how we can do that is we will simply pop up our last character that we added from this current string. So now this is our backtracking step. So actually I will now tell you how it works. So if you see, first of all we are passing the empty string. So we have passed the empty string. So what it will do, it will check this condition. So actually size of start is not equal to this digit size, that is 2. 2. So it will be not equal to that, because our start is 0, as we have passed it 0 here. So now what we will do is we will check for this condition. So it will check for the digits start. So start is 0, so it's you can see 0 for 2. It will check all the possible let I who I wrote it here. So you can see A, B, C. So this vector will contain A, B, C at first. So now what we will do, it will create a string of S. S will be equal to A. So S will be equal to A. Then what it will do is it will check add this S to the current. So our current is also initially empty, because we are exploring our first node, so it is empty. So we will add this to current, and current will be also equal to this. So let me write it. So current will be equal to A. So now what we'll do, it will call the helper function, or itself again recursively by incrementing the start. So start will be incremented, it will become +1, and +1 will be this 3. So it will point to 3, and then it will again come, it will check size is not equal. So no, it is not equal. Then it will create a vector for 3. So it will be this D, E, F. So now for A we will add this D. We are having current as A, so A is our current. So actually I took the example of the 2 and 4 actually. So if you see, if you imagine this is 3, so here we have A, so it will add 3 D here. So you can see D will be added. Current contains A, because A has called for this particular D. So it will be adding A or D actually with the A, and then we will call this helper function, and start will be incremented. So you can see start will become 2 now. It was 0 first for the A, then it called for D, so it become 1. Now it actually 2. Now it will become 2. So now what it will check is it will call this function again. So now our start is equal to the digits dot size. So it will simply add this into our output array, which was our this vector of string result. So it will add. So actually I did a mistake here, m place back. So you can see, so now our current will be added. So our current was A and D. Actually for this example, A and D, it will be added. So now we have explored the possibility for A and D. Now what we have to do is we have to pop back this D from the current. So it will become A again, and it will similarly check for all the possible conditions. So now when it will be ended, it will automatically it will end, and then it will return. We can simply return this result array. So let's see. I hope it works. I have not made any mistake. Let's see. So yeah, let's submit it also. So we get clearer, like it is getting submitted. So yeah, it got submitted. You can see we can run it again. Maybe it like improves the time complexity. So let's see. So yeah, time complexity is coming similar. I hope you understand. So the time complexity for our solution will be 3 power n into 4 power m. So what is this? Actually, if you see, I told you in this you can see 2 maps to 3 characters, and here 7 maps to 4 characters. So if you see, 3 is for the characters we are mapped to only 3 for the digits which are mapped to only 3 characters. For 2, 3, 4, 5, 6 and 8, you can see they are mapped to 3 characters only. But so n will be 1, 2, 3, 4, 5 and 6. So n will be 6 for this particular example, and for 4 you can see it is for the characters which are containing 4 for digits for containing the 4 characters P, Q, R, S, and like this 9, W, X, Y, Z. So for them we are using 4 into m. So this will be like exponential time complexity, and you can see I've written 3 is for digits which have 3 characters mapped to them, and 4 is for digits which have 4 characters mapped to them, and n is a number of these digits actually which are containing these 3 characters, and m is for digits containing 4 characters. And the time complexity and the space complexity will be similar or same actually, approximately, because if you see we are storing all the 3 power n and 4 power m solutions, and for that we have to get a space also, same space also. So our time complexity and same space complexity are similar, and understood like how we can solve this question. And I try to explain you all the backtracking code plus the how we can think of this approach, how we are using the map and all that backtracking stuff, and how we are calling our function. So I hope you like this video, and I have literally tried hard to make this video. And thank you guys for watching this video. Do like this video and subscribe this channel for more, and I will share this code in the description. So if you want to refer this code, you can check it from there. Thank you for watching, guys.